Hello, welcome to another lesson. In this lesson, we are covering network analysis fundamentals, and I'll be explaining the theory behind packet analysis before we get hands-on with Wireshark in our next lessons. So let's dive in. What is network traffic analysis? Network traffic analysis is the process of capturing, inspecting, and analyzing data packets traveling across a network. It is essential for security monitoring, incident response, and threat detection. And the goal is to understand what is happening on your network in real time. You can imagine this as reading the conversations between systems on your network. Every connection, every request, every response is visible in the traffic. And yes, packets don't lie. Everything happening on your network leaves a trace. Now let's consider why traffic analysis matters. Why does it matter? It matters because attacks happen at the network level. Hackers communicate with your systems through network traffic. Also, malware communicates with command and control servers, and it sends stolen data and receives instruction. The next one is that data exfiltration occurs through network traffic, and that might lead to your sensitive data leaving your network. And intrusions leave network traces. Every attack creates patterns in the traffic. That is for the problem. Then considering the solution is that we want to capture and analyze all network traffic. So network analysis helps us to do that. Also, it can help us to detect malicious patterns and anomalies that indicate attacks. It can also help us identify compromised systems that are communicating with attackers and reconstruct attack timelines to understand exactly what happened. Traffic analysis gives you visibility into everything happening on your network. Now, let's understand packets properly because they are the building blocks of network communication. What are packets? Packets are small units of data transmitted over networks. Every network communication is broken into packets, and each packet contains a header and payload. Now let's consider some of the packet components. The first one is the header, and the header contains source and destination IPs, ports, protocol information, and flags. The next one is the payload, and the payload is the actual data being transmitted. And lastly, we have the trailer, and the trailer contains error checking information, which is usually a CRC checksum. For example, when you visit a website, your request is splitted into multiple packets and then sent across the network and reassembled at the destination. Each packet travels independently and may take different routes. So let's see how OSI model applies to traffic analysis. The first layer we'll consider is the layer 2, and that is the data link layer. And this gives us MAC addresses, Ethernet frames, and switch level analysis. The next one is the layer 3, which is the network layer, and it provides IP addresses, routing information, and ICMP messages. The next one is the fourth layer, which is the transport layer, and this shows TCP and UDP protocols, port numbers, and connection states. And the next one is layer 5, which is the session layer, and this has to do with authentication, so it gives us session management details. Then the next one is the layer 6, and that is the presentation layer. So this has to do with the encryption, decryption, and also it gives us some compression information. And the last one is the application layer, which reviews HTTP, DNS, FTP, SSH traffic, application level data, and actual user activities. Most importantly, we are interested in layer 2, layer 3, layer 4, and layer 7. When we are analyzing traffic, we examine these layers, that is the most important ones, starting from layer 2, 3, 4, and 7, and we are analyzing them to get the complete picture of what is happening. Now let's consider the common network protocols. So when you're analyzing network traffic, here are some of the common protocols that you're going to analyze. The first one is the TCP protocol, and this means transmission control protocol. It is connection oriented and it provides reliable delivery with acknowledgements. It is used for HTTP, HTTPS, SSH, and FTP. The next one is the UDP, and this is the user datagram protocol. It is connectionless, unlike TCP. It is fast, but doesn't guarantee delivery. It is used for DNS, DHCP, and streaming media. The next one is ICMP, and ICMP means Internet Control Message Protocol. This handles network diagnostics, and it powers ping and trace routes commands and provides error reporting. The next one is the DNS, which means domain name system, and this translates domain names to IP addresses. It is critical for internet functionality, and it is often exploited by attackers for data exfiltration and command and control. Next, let's consider the TCP three-way handshake. The first one is the SYN, and this is where the client sends a SYN packet to the server saying, I want to connect. The second one is the SYN ACK, and here the server responds to the client with SYN ACK saying, I acknowledge your request and accept the connection. And the last one is the ACK, and this is where the client sends acknowledgement, that is ACK, saying, connection established. Now we can communicate. And why does this matter? It matters because understanding normal connections helps you identify anomalies, and port scans can disrupt this handshake. Also, SYN flood attacks exploit this process by sending thousands of SYN packets without completing the handshake. So knowing what normal looks like helps you spot attacks. Now let's consider the indicators we should look for when we are doing network traffic analysis. So here are some of the indicators of compromise to look for in traffic. The first set to consider are suspicious patterns. And this has to do with usual outbound connections to foreign IP addresses, large data transfers to unknown destinations, DNS queries to suspicious or newly registered domains, and port scanning activity targeting multiple systems. The next one is the malware indicators. And for this, the first one we have there is beaconing, which is the regular connections to the same IP at consistent intervals. The next one is the non-standard ports for common protocols like HTTP on port 8080 instead of port 80. The next one is encrypted traffic to unexpected destinations. Lastly, multiple failed connection attempts indicating scanning or brute force. The last category is the attack signatures, and this is where we have SQL injection attempts that is visible in HTTP requests. We have brute force login attempts with repeated authentication failures. We have exploit payloads embedded in packets, and lastly, command and control traffic patterns with specific beaconing intervals. Now let's consider how packet capture works, that is the basics of packet capture. The first thing we'll consider here is the promiscuous mode, and this is where the network interface captures all packets and not just those destined for it. It is required for comprehensive traffic analysis, and it usually requires administrative privileges to enable. So without it, you only see your own traffic. The next one is the capture filters, and these limit what packets are captured during capture process. They reduce file size and processing time. An example is it only captures HTTP traffic or traffic from specific IP addresses. The next one is the display filters, and these are applied after capture is complete because they filtered capture data for analysis without affecting what was recorded. An example is that they show only failed TCP connections in capture file, and another one is that they display only DNS queries, that is no responses or no other traffic. Now let's consider the traffic analysis workflow. Here is a complete traffic analysis workflow. The first one we'll consider is the capture, that is the step one. And here we are setting up packet capture on our network interface. This is where we define capture filters if we need them, and then we start recording all network traffic. The second step is filter, and here we are applying display filters to focus on relevant traffic. We are isolating specific protocols or conversations, and we are focusing on suspicious activity. And the third step is where we analyze, and here we are examining packet headers and payloads. We are reconstructing TCP streams to see full conversations, and we are identifying patterns and anomalies. And lastly, we have the document stage or document phase, and this is where we export relevant packets as evidence. We create incident reports, which has to do with documenting our findings. We save everything for investigation and legal proceeding. This workflow from step 1 to step 4 ensures we capture everything, focus on what matters, analyze it properly, and preserve evidence. Now let's consider some of the real-world use cases for traffic analysis. The first one is incident response, and this means that we can use traffic analysis to identify how attackers enter the network, track lateral movements as they move between systems, discover data exfiltration attempts, and reconstruct the complete attack timeline. The next one is malware analysis. And that means with the help of traffic analysis, we can identify command and control servers the malware communicates with. We can capture all malware communication for analysis, extract malicious payloads from the traffic, and understand complete malware behavior. The next one is the security monitoring, and this means that network analysis can help detect unauthorized access attempts in real time. It can help us monitor for policy violations. It can help us identify compromised systems and also baseline normal network behavior to detect anomalies. The last one we'll consider is the forensic investigation, and here we are preserving network evidence for legal proceedings. Also, we are proving or disproving security incidents. We are supporting legal proceedings with solid evidence, and we are giving attribution of attacks to specific threat actors. Now, let me introduce you to Wireshark. What is Wireshark? Wireshark is the industry standard packet analyzer. It is free and open source. It is cross-platform, that is, it runs on Linux, Windows, and Mac, and it is the most widely used network analysis tool worldwide. Now, what does Wireshark do? It can capture live packets from network interfaces. It can do deep protocol inspection of all layers. It has powerful packet filtering and searching capabilities. It can do protocol decoding and stream reconstruction, and it also helps export packets and data for further analysis. Wireshark is very important because of its comprehensive protocol support for over 30,000 protocols, and it has this visual representation of traffic patterns. Also, it has these extensive analysis features for professionals, and that is one of the reasons why I love Wireshark. So in the coming lesson, we are going to get hands-on with Wireshark. Now, what are the key takeaways from this lesson? The first one is that network traffic analysis reviews everything happening on your network in real time. The second one is that packets are the building blocks of network communication. The third one is that understanding protocols like TCP, UDP, ICMP, and DNS is essential. Also, the TCP three-way handshake is fundamental to all connections. The next one is look for indicators of compromise, such as suspicious patterns, malware indicators, and attack signatures. Also, do not forget to follow the workflow, capture, filter, analyze, and document, always in that order. And we also consider the use cases, which include incident response, malware analysis, and security monitoring. And this one is very important. That is, before you capture anything on any network, ensure you get authorization. Do not run anything as touching network traffic capturing without proper authorization. And lastly, Wireshark is the industry standard tool for packet analysis. That's all for this lesson. But before we go, I have a question for you, which is a challenge question. And the question is, what are the 4 steps involved in network traffic analysis workflow? I'll take it again. What are the 4 steps involved in network traffic analysis workflow? That's all for this lesson. If you're here to subscribe to our YouTube channel, please do that now. Also, do not forget to like, share, and comment. I would like to see the answer to the question I asked you in the comments, and I'll be replying them myself. Thank you so much, and see you in the next lesson.